Welcome to the deep dive. What if I told you that the strongest proof for a higher power isn't found in, some ancient philosophy or by looking at the biology of a cell?
Right, which is where people usually look.
Exactly. But what if the ultimate proof is actually hiding in the strict cold laws of quantum physics, mathematics, and data compression?
It completely flips the traditional debate between naturalism and theism right on its head.
It really does.
Hmm.
Because today, you and I are unpacking this fascinating, highly complex, revised dissertation framework. It's titled Information, Transcendence, and Anthropological Design.
It's quite a title.
Yeah, it is. But our mission for this deep dive is to explore the author's unified theory. They synthesize physics, math, and cognitive science to argue that the sheer existence of, information
Mhm.
logically compels a belief in a transcendental ground.
Which basically means a reality outside our physical universe.
Right. Okay, let's unpack this because it is incredibly dense, and we need to start by shifting how we even define information, don't we?
We do. To grasp this, you really have to rethink the word information completely. Because typical debates about the universe usually operate on what is really impoverished information ontology.
Like assuming information is just a label we put on things.
Exactly. If you talk to a strict naturalist, they typically assume information is just physical stuff moving around, and human beings just slap the word information onto that movement to make sense of it.
Or, on the flip side, someone arguing for a higher power might treat information as just divine psychology, thoughts in a cosmic mind.
Right, but this text argues that both of those views totally miss the physics. Information is an actual fundamental physical property of the universe.
Which brings us to Landauer's principle.
Mm-hmm.
And I have to say, when I first read this part, it completely broke my brain.
Oh, it's wild. It's a total paradigm shift.
Because I've always thought of information as weightless, right? Like the number 7 doesn't weigh anything. An email doesn't have mass.
Yeah, we think of it as abstract. But Rolf Landauer, he was this brilliant physicist at IBM. He proved mathematically that information is a physical reality.
And how did he prove that?
Well, he showed that any logically irreversible manipulation of information, so for example, erasing a single bit of data from your computer's hard drive, that action actually must increase the entropy of the physical environment.
Wait, really? So erasing data costs physical energy?
Yes. It literally generates a tiny measurable amount of physical heat. You simply cannot separate data from physical energy.
That is so weird to think about. So me deleting the spam email from my phone technically warms up the physical universe.
Technically, yes, it does.
Wow. But the implications get even crazier when we look at the limits of space, like the Bekenstein bound and the holographic principle.
Yeah, this is where classical physics just starts to break down. The Bekenstein bound dictates that there's a strict mathematical maximum amount of information that can fit inside any physical volume of space.
Okay, that makes sense, like a hard drive having a storage limit.
Right. But the counterintuitive part, and this genuinely shocks people, is that this maximum limit is proportional to the surface area of that volume, not the 3D space inside it.
I need to pause here because that is so hard to visualize. If I have a cardboard box, my common sense says the amount of stuff I can fit inside depends on the empty 3D space in the middle.
Right, the volume.
Yeah, the volume. But you're saying the universe calculates the information limit based on the 2D surface area of the cardboard walls.
That is exactly what quantum gravity suggests. And if you take that a step further, it leads right into the holographic principle in string theory.
Which is the idea that the 3D world is an illusion.
Well, sort of. If the maximum information of a 3D space is constrained by its 2D boundary, physicists think our entire three-dimensional reality might just be encoded on a two-dimensional surface.
Like the shiny hologram sticker on a credit card.
Exactly. It looks fully 3D, but it's just an illusion created by 2D data. So the information is the bedrock, and physical matter is just the 3D projection of that data.
Okay, so the universe is built on a bedrock of compressible data. And that brings us to the core of this whole thing, the information theoretic transcendental argument, or the ITTA.
Yes, the ITTA. The text points out that our universe possesses this profound compressibility.
Also known as Wigner's problem, right?
Yeah.
The unreasonable effectiveness of mathematics.
Right. What's fascinating here is that it is entirely unreasonable when you really sit down and think about it. You take these incredibly chaotic natural phenomena.
Like a turbulent river or a storm.
Yeah, or the chaotic birth of a star. And somehow all of that can be perfectly compressed into incredibly simple, tiny mathematical equations.
And it doesn't have to be that way. Like, we could easily live in a completely algorithmically random universe.
Exactly, a reality where nothing makes mathematical sense, where you drop an apple and it does something completely unpredictable every single time.
It's just uncompressible noise. But ours is highly structured.
And the standard naturalistic response is to look at this stable regularity and just shrug and say, well, that's just a brute fact. That's just how it is.
Right, like, science explains things based on those laws, end of story.
But this is where the ITTA strikes its hardest blow. The author argues that scientific explanation itself requires these highly ordered information structural conditions to even exist.
So is it kind of like a video game?
How do you mean?
Like, imagine a highly intelligent video game character suddenly realizing that the highly organized, compressible pixels of their world operate on strict math.
Okay, yeah.
Those pixels can't explain their own structure using the code inside the game. The very fact that the code exists logically requires a computer server like a hardware ground sitting entirely outside of the game.
That is a perfect analogy. The structured pixels cannot be the source of their own structure.
But let me just push back here for a second because I can hear the naturalists screaming through my headphones.
Go ahead.
Why can't science just explain it eventually? I mean, we don't have the ultimate theory of quantum gravity yet. Why do we have to jump to assuming a transcendental ground outside the universe? Why not just wait for physics to figure out the deeper law?
It's a fair question, but the text clarifies that this falls into a meta-explanatory trap. Attempting to use science to explain why science is possible is self-undermining.
Because it's circular.
Exactly. It's a circular argument. Science works by formalizing and compressing natural phenomena. So if you try to use the scientific method to explain why the universe is compressible enough to allow for the scientific method,
You're begging the question.
you're totally begging the question. The conditions that make explanation possible cannot be explained by the system they create. The framework concludes they have to require a source outside the physical system.
Okay, I follow that logic. So if the universe's baseline information requires this outside ground, the natural next question is, would that transcendental ground ever leave a recognizable physical trace inside our universe?
Right, like an Easter egg from the developer in your video game analogy.
Exactly. And the framework formalizes this as the empirical signature thesis, right? How we would spot the ground.
Yes, and it sets up 4 very strict criteria. If a signature exists, it must have, first, holographic encoding. Second, anticipatory structure, meaning the information references future interpretive frameworks that didn't exist when it was made.
That's a big one.
It is. Third is self-authentication. It verifies itself without outside historical proof. And fourth, information without a physical antecedent.
Meaning there's complex data there that has no sufficient physical cause for existing.
Exactly. So the text outlines 2 test cases, or modalities for this. The first is pure math, the mathematical modality. They use the pi message scenario, which Carl Sagan popularized in his book Contact.
I love that concept. It's like, imagine you're scrolling through millions of lines of totally random computer code, and suddenly you find a perfectly formatted Shakespearean sonnet.
Right, something that statistically shouldn't be there.
Yeah. The idea is that buried deep inside the infinite digits of pi, there might be a mathematically encoded message.
And if we found that, it would perfectly meet all 4 criteria. It has no physical antecedent because it's math. It has anticipatory structure because it would have just sat there since the dawn of time, waiting for humanity to invent supercomputers capable of calculating pi far enough to read it.
It's an always existing mathematical revelation.
Exactly.
But the framework goes beyond math. It explores a physical modality too. And for its physical archetype, it uses the Shroud of Turin. Now wait, the Shroud of Turin, isn't that a highly debated, potentially politically or religiously charged topic? We need to be careful here.
We absolutely do, and it's important to clarify that we are strictly maintaining impartiality, just reporting the dissertation's argument. The author explicitly states that the shroud's temporal origin is entirely irrelevant to the point.
Wait, really? Irrelevant?
Yeah.
Whether it's a first-century artifact or a medieval forgery?
Completely irrelevant. The text uses it solely as a physical archetype of anticipatory structure and holographic encoding. It's about the empirical reality of the object itself.
Okay, so what makes it an archetype?
Well, the image on the shroud contains 3-dimensional spatial data encoded into the superficial shading of a 2-dimensional piece of cloth.
Right, vertical collimation.
Exactly.
Because if you take a standard 2D photo of my face, the light and shadow just tell you where the lamp was in the room. A computer can't look at that 2D photo and extract actual depth data, like exactly how far my nose sticks out.
But the shading on the shroud actually does contain that distance information. The image intensity correlates directly to the cloth's distance from the body.
And this is where the anticipatory structure comes in, right? Because decoding that 3D holographic info required 1970s computing technology.
Specifically the VP8 image analyzer, yeah. The same tech NASA used to map planetary topography.
So the argument is that regardless of when it was made, the object contains complex 3D informational structures that perfectly anticipated a technological framework that wouldn't exist for centuries.
Right. It's information without a physical antecedent. It serves as a measurable model for what a physical signature of the ITTA ground would look like.
Okay, so we have a hypothetical universe built on transcendental information and potential complex signatures hidden in it. But this raises a glaring biological question.
The recognition problem.
Yeah, why are we capable of recognizing them? Our brains evolved in the Pleistocene environment, right? To survive, to recognize faces, spot snakes in the grass, find food.
Right. Which brings us to the anthropological design thesis. Because there's a massive evolutionary mismatch here.
Let me bring up objection 7.3 from the text, because an evolutionary psychologist would jump on this. Couldn't they just argue that our ability to understand quantum physics or 3D tomography or pi is just a spandrel?
You mean a lucky byproduct of humans just having general intelligence?
Yeah, like we got big brains to hunt mammoths and oops, a million years later we can suddenly do calculus.
The text actually refutes that pushback head-on, because general intelligence is incredibly biologically expensive. The human brain uses roughly 20% of our daily calories.
That's a huge energy cost.
Massive. And evolution is ruthlessly efficient. It does not fund expensive hardware without a direct survival payoff. Developing a brain meticulously calibrated to recognize complex ITTA patterns or holographic structures offers absolutely zero survival value in the wild.
So a hunter-gatherer doesn't need to understand Wigner's problem to outrun a tiger.
Exactly. If we connect this to the bigger picture, the author argues this points to intentional informational design. Human cognition fundamentally mirrors the ITTA signature itself.
Wait, how does it physically mirror it?
Think about conscious experience. It compresses massively high-dimensional information sites, sounds, abstract concepts down into the physical neural substrates of your brain.
Oh, wow.
Yeah. Our cognition is inherently holographic. We compress data. This indicates our minds were specifically calibrated to the transcendental ground, not just survival evolution.
Okay, so we're specifically calibrated to read these signs, but why is this realization only happening now?
That leads to the final puzzle piece. Informational eschatology.
Which sounds like a really intense sci-fi movie title.
It does, but it's based on the idea of progressive disclosure. The truth reveals itself systematically as human knowledge matures.
So the ground only reveals itself when the interpretive community exists to receive it.
Exactly. Look at the timeline. In the era of photography, suddenly we can see physical anomalies, like the shroud's photographic negative archetype.
Right.
Then we hit the computational era, and we find mathematical anomalies, like calculating pi or using the VP8. And now, in the information physics era, we're recognizing cognitive anomalies, the whole ITTA framework.
Here's where it gets really interesting to me. It's like a cosmic escape room.
Oh, I like that.
Yeah, like the invisible ink on the walls of the escape room only appears once you've successfully built the blacklight to see it.
That's a great way to put it. The universe waits for our physics to catch up to the Easter eggs.
But let me ask you about the many worlds escape hatch. Because objection 7.2 brings up the multiverse theory. A naturalist could say, sure, our universe has this infostructure, but there are infinite chaotic universes out there, and we just got lucky.
The multiverse is the ultimate fallback, but the text has a rebuttal for that too. Even a multiverse generator requires information structural conditions to function.
Right, like branching laws or inflation mechanisms.
Exactly. The ITTA just moves up a meta level. It's a closed system. Any physics you use to explain the multiverse will inherently embody the exact ITTA structure that requires an outside ground.
You can't use the rules of the system to explain the origin of the rules.
Precisely.
Wow. So to bring it all home to you listening right now, the next time you zip a file on your computer or solve a math equation or just reflect on your ability to imagine the future, consider that you aren't just thinking.
No, you're not.
You might actually be interacting with the foundational mathematical boundary lines of reality itself.
And to leave everyone with a final, truly provocative thought from the future research section, we've talked about the boundaries of physics. But what about the quantum measurement problem?
Oh, right, the idea that particles are just probabilities until they are observed.
Right. The text proposes that the human observer might be the actual physical ITTA nexus.
Wait, really?
Yes, the exact point where transcendental information physically collapses into reality just by us looking at it.
So human consciousness is the bridge. Just by opening our eyes, we force the infinite data to compress into physical reality. That's a lot to ponder.
It definitely gives you something to think about the next time you wake up and look around.
Absolutely. Well, thank you for joining us on this deep dive. Keep asking those big questions, and we'll catch you next time.